Hello, Vilnius. Thank you for joining my presentation today. So first of all, I need to tell you guys that please send your questions via Slido. Right? And this picture describes best what kind of challenges I'm dealing with on a daily basis. And I believe I'm not the only one, but if you are lucky enough to use only one tool or service from each of these squares, please talk to me at the end. I'll buy you a beer. Like that was not enough. Welcome to the landscape of serverless. Invented by AWS and joined by all other major providers like Google Cloud and Microsoft Azure. Right? Serverless is quickly becoming a parallel universe. Please raise your hands if that's something that is too much for you guys to deal with. Okay, I guess I'm the only one. All right, let's move on. My name is Eugene. I'm the Chief Technology Officer of Mito Group. We are a cloud-native automation company. We were born around the time when AWS released in beta their product now associated with serverless, AWS Lambda. These are my credentials. I won't spend too much time talking about myself. I'm not a I usually don't brag about myself. But today I would like to discuss how we felt overwhelmed by these constantly evolving services and tools, and what we did in order to keep up with latest emerging technologies that are compatible with legacy as well as with the cutting-edge solutions. Right? The devil is in details. So we are striving to make IT simpler. I hope that's funny, because good luck with that. Okay, but nevertheless, a smart guy once said, "When something is important enough, you do it even if the odds are not in your favor." Well, history shows that he was right. So, after a short description of the problem and a small explanation into how we think about solving this problem, I'll dive into Terraform for serverless. So next, let's make sure that we are all on we have the same understanding about three major concepts. Right? What is IT as a service? Right? What is DevOps? And the overall scope and boundaries. So first, IT as a service spectrum, right, spreads across on-premises, colocation, hosting, infrastructure as a service, platform as a service, and software as a service. As you can see, the services are more or less the same in each of these categories, right? But the difference is whether the customer is managing these services or not. Now, speaking of serverless, I've seen several definitions of serverless, but my favorite is actually this tweet by Adrian Cockcroft. He's a former chief architect at Netflix, and now he's a VP at Amazon Web Services. So he says, if your platform as a service can efficiently start instances in 20 milliseconds, and that runs for half a second, at least half a second, then call it serverless. So in that context, in the serverless universe, we generally assume and agree that platform as a service and software as a service are in scope. Everything else is out of scope. Okay? Now, second, DevOps spectrum includes all development operations that we as engineers must go through in order to manage our IT needs end to end. It doesn't matter if it's you doing it internally or through third parties. So these includes agile development, continuous integration, continuous delivery, continuous deployment, and that are all part of DevOps. Right? So it's not optional, and definitely not out of scope. Okay? And third, if we go back to the DevOps landscape, mark deployment services and tools as A, configuration management and provisioning as B, orchestration and scheduling as C, Terraform is basically B, but Terraform for serverless is A plus B plus C. So there you go. Thank you for your patience. This is the core of our presentation. So now I'll go, now we're ready to talk about best practices and lessons learned from using Terraform for serverless. Best practice number 1 is to adopt microservices architecture. Right? This might sound trivial to some of you guys, but I still come across engineering teams or companies who still don't apply this. Right? So just a heads up disclosure, I will provide examples for each of the best practice that I will be talking about. There will be 8. To be clear, these examples are not wrong, right? It's just, but rather indication that something can be done better, can be improved. Right? That's why we talk about best practices. So in this particular case of a microservices architecture, so instead of putting all of your resources into one Terraform configuration file that generates one TF state file, break it down into smaller components, smaller pieces, right? Aim for one-to-one relationship between the serverless resource and the Terraform configuration file. After you break it down into microservices, you can use built-in functionality to pass, Terraform built-in functionality to pass variables between the resources. Right? So it's called Terraform remote state. And let me show you an example. So if you have 2 services that needs to reference the same variables, usually people do it like this. Right? You hard code values, or you put the values in both Terraform configuration files. So instead of doing that, define, for example, the service 1, right? Enable Terraform backend, like we do in this example via S3, expose it into output, and reference it in the service 2 using the data Terraform remote state. Okay? So the third best practice is avoid using local provisioners and external data. External data to execute external scripts. Right? In our experience, it was actually very difficult to identify issues when something goes wrong. So, like in this example above, the data external would trigger the execution of the build.js node script every time when a Lambda function will be created or updated. So I hope you understand where I'm going to. We as a team, our team at MITA Group, we agreed among us that we will never see this kind of code in our repository. Instead, we're using orchestration, Terraform orchestration tools, right? Like TerraGrant or Atlantis or TerraHub, which is our homegrown orchestration and automation tool. And I put here an example of how we're using it in TerraHub. Next one, when we developed serverless applications, we ended up with a lot of Terraform components. Right? Managing manually, it's really difficult. But unfortunately, automated Terraform workflows are not a built-in component in this open source tool. So either you do it by yourself, and Terraform, there is a page in Terraform.io that shows you how to do automated workflows. Or use one of these orchestration tools that I mentioned earlier. Or use I know how many of you are using Terraform Enterprise. They have built-in capabilities in there. Okay. So to be factually correct, I must mention that Terraform has a built-in option called Parallelism, but it doesn't work across different Terraform components. It works only in one Terraform component, right? So we ended up adding this feature into the TerraHub CLI. And this is one of the most commonly used features that we have in the CLI, which is, by the way, it's open source. Very often, we don't need to run automated Terraform workflows for all of the components. And for example, I have 100 of them, but I need to make changes only to a couple of Lambda functions, maybe to an API gateway, and that's it. Right? So instead of specifying a static list of components in the CLI, we use Git, where we're using Git diff to dynamically see what have been changed across commits or in a specific pull request. Okay? And then execute automated workflow on the map of components that changed. So for example, like in this example, we're having here 9 different components. Okay? And instead of running the automated workflow on 9 different components, using in TerraHub CLI the Git diff feature, it reduces the list down to 2. So that's an almost 80% improvement, and I don't need to wait for all of them to be executed just because I made changes to 2 of them. Another one is, so one way to separate environments is to have separate code bases for each environment. Right? We don't do that. Instead, we use Terraform Workspaces to logically make the separation across environments. Right? So instead of having 4 versions of exactly the same code with probably some variables different, or maybe even some configurations different, we do it. We're using Terraform Workspaces, which by default, if we want, we enable development environment to be the default default workspace, and the other environments we're setting up for testing, staging, production. Right? We use also the Terraform orchestration tool to switch between environments as easy as adding --env, and whatever name you put on your environment. We use dev test prod. If you want to do development, testing, production, you can do that, or you can name it as you want. Another best practice is to built around Terraform variable precedence. So instead of, again, putting values and hard-coding values across different Terraform workspaces, we're storing the same value in a different TF-var, right? We're storing all the values in the default TF-var, and only the values that are different for your specific environment, that's the one that we're putting in a different TF-var file. And when we run this automation, right, when you run Terraform plan or apply, you just need to specify the first one, the default, and the second one, the environment specific. So the values from the environment specific will override the values from the default environment. Okay. So this is a Terraform native feature. You can read it using this link. And finally, get used to a lot of Terraform, or don't. Like for example, we have a project where we have around 34,000 lines of Terraform code, right, that has over 100 Terraform components. When we switched to a YAML-based approach using TerraHub CLI, we ended up with a little over 22,000 lines of code. That's over 30% reduction of our code base, and we still believe that we can decrease it even further. And another benefit of using YAML versus HCL is that you can seamlessly convert them from one format to another format. Well, to summarize, I discussed today only 8 best practices. There are much more than we can dive in, and I don't have the time to. I would like to show you a demo, and I'd like to show you hands-on how we do some of this stuff. Right. So all the lessons learned that we have, learned while working with Terraform for Serverless, we included in this open source tool, right? TerraHub CLI. It's a Terraform orchestration and automation and orchestration tool. So if you like this project, please help us out and leave some stars on GitHub. So that being said, I guess we have enough time to do a demo. Let me switch to all right. Where is it? I think I do like this. Let me exit the screen. Okay, now it's better. So in the slide before, this is the Git repository for the demo that I'll be doing today. And I'll do this demo in 3 stages. The first stage, I will run it locally on my computer. Right? I hope the internet connection is good for me to actually do that. Then, hopefully, after successful execution, I'll run this in a CI service. So I chose Jenkins. Please don't judge me for that, but it's functional. Right? And the third step, I want to show you how we've fully automated the entire process. We're basically only opening a pull request in GitHub, and then everything happens magically behind the scenes, right? So let's get started. I will. By the way, can you see this one? Yeah. Okay, this is the best that I can get. So I will actually decrease. I will skip the first 2 steps. I assume everybody knows how to create IAM credentials. If you guys don't know, reach me at the end. I'll guide you into some of the documentation, or just follow these steps. All right. So the next step is so Terraform is everything is explicit, right? You need to write down different variables, different configurations in the files. Since this is a public repository, but I have some private values that I don't want to disclose, like an account ID, I added here 2 steps that automatically defines the account ID and the region based on what credentials I'm using right now for my AWS account. So that's what I'll do first. Okay. So I'm setting up my AWS account. I will not show you what value it is, but I'll show you the second one, right? So if I do AWS default region, it set it up on US East 1, right? Let me also increase this one a little bit. So next is I'm using TerraHub CLI. The same thing you can achieve with other CLI tools. I'll copy paste this one because I'm building everything from scratch. And basically what it does is just create the folder, enter into the folder, and initialize this as a project. So everything that it did, it created a terrahub.yaml file. And if I look into this YAML file, it's a template, and it shows you created the name of the project, code, and some of the Terraform configuration that we're defining for the entire project. Then let me copy only this. I intentionally will skip the last one. Okay, and let me do one more time and show you that now it updated the values, right? And it included all the configurations that I want to be specific to my project. Okay, so I'll also add this one here, and let me start creating components. Okay, so now if I show you over here, now I have new folders. In each folder is a component, is a Terraform Terraform configuration. By default, it's just the template that comes in with our CLI. You can customize it, whatever you need to add. So I showed you just one example for VPC. And now the next one will be customizing all this components. All right. So again, now I customized basically here. I created the CIDR block, assigned the IPv6, enabled classic link, false, enabled DNS, enabled support for host names, right? And the same thing I'll be doing for the other components, but in order not to copy paste, just created the run script that will do everything for me. So while it's doing it, it basically runs all these commands for IAM role, for Lambda function, for API gateway, the REST API, and then the deployment is separate for deployment of the API. Okay? So okay, it's done. Now, TerraHub graph is basically shows you the dependencies between components, and we show here that we have two components that don't have dependency. They are not dependent to anything, like IAM role and VPC, and then everything else is dependent from each other. So security group is dependent from VPC, right? The subnets are dependent on VPC. The Lambda function, you need the IAM role, but you also need the subnet, which here is not showing it, but it just shows you like one dependency in the graph chart, right? And so on. So once I'm done with this, we have a command that is not just a wrapper around the Terraform command, and it's build. So I'll talk about that later, but what we are doing is adding extra capabilities of Terraform, like for Lambda function, the native Terraform capability, you just need to point to a zip file, right? But you guys don't store all of your code in zip files, right? You need to compile, you need to transpile, you need to do a lot of other minification, a lot of other stuff that it doesn't come out of the box. So that's why we build this additional command where it helps you to automate the build step as well as part of the workflow. Okay. So last but not the least, running the automation, and it shows you that it will be running the automation on the 3 components, and it failed because I forgot something. Yes. Why did it fail? I forgot to do something here. It says input is disabled. All right. Sorry about that. So since I'm running late on time, I'll switch to the second step, and I'll come back if we'll have time to this one. I promise it was working before. So the second step is, as I said, I run on a local machine, assuming it's working. All of my Terraform code, which I didn't show, but it uses the local storage for the backend, right? Uses local backend. Now, if you run in a continuous integration service, right, you don't want to use the local storage. You want to use the remote storage, right? So you want to use something like S3 or Google Storage and stuff like that. So this Jenkins job that I created over here, it does that. It takes the entire code. It takes, you cannot see it very well, but it takes the code, then it creates those AWS account ID and default region, right? Makes the changes, so switches all these Terraform configure command lines. It switches the local backend to remote backend powered by S3. So let me go over here and just start one of these builds. All right, and what it does, it does exactly the same like in previous demo, right? It does all the changes to the configuration. Once the changes to configuration are done, it starts running the automation. And TerraHub run, it's just one command, but actually what it does, it executes Terraform init, then Terraform Workspace, the Terraform init workspace, build if you have a build, then plan, then apply, right? And then at the end, if you want, and you enable it, you can also run the destroy. So this is the entire workflow. Apply and destroy are optional. They are not enabled by default, but you can enable them either in the YAML file, in the configuration that you want all the time to run apply, or you can enable it through the CLI. Right? If you do -- apply or -- destroy, it will execute it automatically for you. Okay, now I have another error that for some reason oh, I'm sorry. Guys, I was preparing for this demo. Just 1 second. I was running the wrong command. I was running the destroy command instead of the apply. Okay. So while it's doing, I guess I'll move on a little bit so we don't run out of time. This CLI, as I said, we've built it because we solved our own problems into managing Terraform and automating the orchestration of the Terraform, which we didn't find in other tools. After we had the CLI fully functional, we learned that it will be easier to see something in the UI. And that's what we did, right? We created a website that is powered by Serverless as well. And here, just go into the UI itself, and I'll introduce my username and password. We wanted to see everything that you're doing on the CLI side, something nice in the UI. So I won't be using this one. I'll be using this one for demo purposes. And I have a very weird email. So you can imagine we tried it 15 times until we got it right. And there you go. This is the project that shows in your dashboard all of your resources that are associated to this project. And it's generated based on the TF state files that you coming from your project. Right? But this is more interesting, the real-time capability. So everything that you see on the left and the right, it shows you in a nice real-time UI, where you have, I'm not sure if you guys can see it. Here it says init, here it says workspace, here it says plan, here it says apply, and here it says destroy. This is the list of components and the names of each component. And here, as you can imagine, check is positive. This weird icon, it means it skipped this step because it's already, in this particular case, it's already default environment. So we didn't change actually we didn't switch the workspace. This one, the plan, it shows that it's successful. When it's a yellow one, like in this case, it says right now it executes that particular component, right? The Terraform workflow for that particular component. And then the red ones, as you can imagine, are the ones that it says it failed. So I see here it was the one probably that I tried earlier, and something failed. All right, let's come back to this one and focus on this one. So, So it says on the left that we successfully executed the Terraform automation, and on the right, it's still catching up for some reason. So, not blaming anyone, but the internet connection still has some issues. That's why it doesn't update real time. So coming back, this was my second stage of the demo, right? I wanted to show you that it runs in the CLI, first in CLI, second in the continuous integration service. So now I need just to go back here and run a destroy command, which will take and basically clean up all these resources that I've provisioned here. Okay? I'm cleaning them up because, again, it's the way we wrote the Terraform is that it provisions exactly the same resources. And if you already have the resource, for some services, it will give you an error, right? If you try to do the same Lambda function, create the same Lambda function. For other services like API Gateway, it will create a new API Gateway, right? So that's why right now I do a cleaning. I think this just lost connection. So you can see the previous was successfully executed. Come on. The previous was successfully executed. All the applies green. This one, though, is still work in progress. And now it will skip the apply step and will go directly to the destroy step. Right? I don't need to run any applies because I'm just cleaning up my resources. Right? And another use case, actually, for testing purposes, if you just want to know if your Terraform works, right? You just run this one and do apply and destroy automatically, and you just have the entire log and you see which failed, which was successful. Okay, so for QA use cases, you want to run apply to see that it's working, and then just automatically destroy. I don't need it anymore, right? Okay, so while this is doing, I'm going to the third step, and my third step is basically I'm also here in the same repository, right? And I want to do something crazy. I want to open just a pull request and do nothing, right? So that's what I'll do over here. Let me switch to dev environment, and I'll just create a new branch, demo conference. Okay, and let me change something here that it actually sees that I can open the pull request, right? Okay, that's fine. Remove this line. I don't need it anyway. Okay. And I'll go back to my, I have here now that I open pull request, and I don't want to open it in master, I want to open it in dev. unless you guys want to open it in master, but I don't recommend. All right. And there you go. So what happens is, so we create also a GitHub application that includes your checks and gives you the logs automatically in the pull request, where you don't need to go in back to your CI/CD service, analyze all the logs. You'll be able to do everything from GitHub or from another code management system. And so right now I go back here and wait for the new build to start. All right. It's actually, so with GitHub, it takes a little bit more time. First of all, because before we launch the continuous integration, in case of GitHub, we use not Jenkins, but code pipeline. So we're using all the Amazon native services because that's what we use as a cloud provider. Right? The same thing we'll be doing for other cloud providers. And there you go. It actually failed. And that's something expected. The failure is expected because we are bad developers. And the way we build API gateway, we are looking for a Terraform state, a TF state file for Lambda function, or the other way around, that actually doesn't exist. Right? So we need to improve our code. But I wanted to show the failure, because once that's done, it will show you a check. Right? It tells you that it took 1 minute. Unfortunately, that's not true. And it gives you a bill. It gives you the log, which you can open, and you can go and you can analyze your log to see what happened and why it happened. Right? We know why it happened, so instead of I say, look, I know why it happened. I'm aware of it. Let's say it was successful. So I do an approve, and it launches another execution, right? And that another execution, I can also see in this console, right? So that's the previous one. Hopefully, the new one will start really soon, because I'm actually running out of time. And we'll have a successful execution. All right. Well, while we're waiting, I have 2 more slides. So hope, guys, you have. Okay. So before leaving today, I would like to close my presentation with this quote from Amazon's AWS CEO Andy Jassy that says, "There is no compression algorithm for experience. So try it yourself and let me know how it goes." All right. So that's a little bit. I'll put it back in at the end. Let me just. There you go. So this is running. Okay. And I have 2 more components. As you can see, they are not running in parallel. There are 2 reasons. The first reason, because they're dependent from each other. So you need to wait for Lambda, for API gateway. API gateway needs to wait for Lambda. Lambda needs to wait for IAM role, and so on. The second one is because it runs on just one server, right? And I was hoping that I'll have time to show you how we're doing it distributedly just with Lambda, but I'm running out of time. So, okay, that's pretty much it. I hope this one, just give me 1 minute. I hope this one will be successful, because otherwise,
yeah, sure.
Otherwise we miss the whole point, right? You stayed, guys, here for 40 minutes just to see failures. Yes. All right. Thank you very much.
Thank you very much, Eugene. Maybe we have some questions from the audience.